Hey guys, so today I'm gonna have you fill in some notes for yourself in your fall semester toolkit. So this is still working on the one that we got last semester. We're gonna be looking at chapter 1 here, functions. We're not gonna fill all of it out today, but we're gonna fill out a good chunk of it. So if at any point you feel like I'm going too fast, you can always pause the video. If you feel like I'm going too slow, you might be able to watch it on double speed, whatever you need to do this activity today. So let's get started. A function. So what is a function? We've been exploring that a little bit. A function is a relationship, and it should have no more than one output or y value for each input. Those are going to be our x values. So in other words, the function, in order to be a function, we should have a consistent and predictable output. Right? If I input a number, the function is going to tell me what to get out. It's going to be the same every time. When we write a function, we have x as our input, and we have f of x as the output. Now, f of x is a lot like y. The difference is that it tells us for a given y value or output what the input was, right? So that's the purpose of writing it like this, f of x. And I actually want you to write that in here, f of x. We're not multiplying. It's a different operation or different thing when we're talking about functions. So the basics of how this works is we have an input, x, and then some stuff happens to it. There's like a rule that happens or some math. And then we get the output, f of x. We call that our output. So let's take a look at an example. We're going to use this rule here. This rule says that we're going to multiply x by 3. We're going to subtract 5, and then we're going to take the square root. And so we're going to take a look at what happens when our input, the number we put in here, is 10. So to evaluate f of 10, we want to take the square root of 3 times 10 and then subtract 5, because that's what our rule says we want to do. And at this point, I would strongly encourage you to use a scientific calculator if you are not feeling super strong in your mental math skills or your order of operations. But what we're going to end up with is that this is like the square root of 25. So our output is going to be 5. And we can write that as f of 10 equals 5. That is our output. We're going to talk more about domain and range in the future. So for right now, I'm going to move on to the second page of chapter 1. So there's certain things that we can do with evaluating functions. Right? Sometimes we want to find the input, sometimes we want to find the output. And for the purposes of these examples, we're going to use a specific function. We're going to look at f of x equals the square root. Oh, sorry, not the square root. We're going to look at negative 5x squared plus 3. And we're going to look at 2 examples today. The first one is I want you to evaluate f of 3. And the second one, we're going to evaluate f of negative 2. So to do this, we want to recognize that our input, x, is 3. That's what this is telling us, right? So we'll look at our function, and to find f of 3, we want to multiply by -5, square the input, add 3. That's what our rule tells us to do. And I'm going to show the steps here. We do want to remember PEMDAS as we go through this. So we have f of 3. We want to do -5 times, we want to do 3 times 3 first, right? So 3 times 3 is 9. So that was our exponent. Next, we want to do our multiplication. So we'll do -5 times 9 is -45 plus 3. Finally, there's no division. We'll want to do our addition to get -42. So all in all, we can say that f of 3 equals -42. Let's look at another example. So evaluate f of -2. In this case, our input, the x value, is -2. So if you'd like, you can pause and try this one for yourself. I encourage you to use a scientific calculator. There's a great one online if you just look up scientific calculator. So pause it, try it for yourself, and then I'll give you the answer in a little bit. Okay, did you try it for yourself? Hopefully. So let's take a look here. We want to do f of -2. So we're going to plug it into our function. And we're just going to calculate it out, right? So remember, at this step, you can always use the calculator. I'm going to do step by step here. So -2 times -2 is 4. Where -5 times 4 is -20. And we get our solution, -20 plus 3 will be -17, which tells us the output when the input is -2. So that's one type of problem that you might see. The other type is, so that's where we were given the input. There are other problems where we might be given the output. So for example, instead of find or evaluate f of -2, I might ask, find x, the input, when the output, f of x, is -2, right? So instead of saying I want you to plug in -2, what I'm saying is that the output, f of x, is -2. So that's going to look different when we're plugging it into our equation. So instead of plugging it in for x, that's not what we're doing. We're trying to find x, right? So don't plug it in for x. We want to plug in the output as -2, and then think backwards to solve for x. All right, so in this case, we can't write something for x. We don't know what it is. And then we're going to solve. So you can solve like you normally do, right? We want to get x by itself, so we'll do some opposite operations. In this case, I'm going to subtract 3 on both sides. I'll get -5 equals -5x squared. Still trying to get that x by itself. We'll deal with the squared in a little bit. So we're going to divide by -5 on both sides. So we'll get x squared equals 1. We'll talk a little bit more about solving these types of equations next chapter. But for now, I want you to think, what number can I multiply by itself? What number can I square to get me to 1. Because that's really what this equation is asking. It's saying a number squared equals 1. And it turns out, super weird, there's going to be 2 solutions. There's 2 different numbers that I can multiply to get 1. Can you think of what they are? So we're going to say 1 times 1 equals 1. But also negative 1 times negative 1 equals 1. So we really get 2 solutions here. X is 1, and x is negative 1. 2 different solutions. So just be careful when we're solving this type of problem. We don't plug in a value for x at the beginning, because that's what we're trying to solve. So you just have to be careful about what the problem is asking. Is it looking for the input or the output? And go accordingly. Thank you, guys. I will see you on Thursday.